All right, so I guess I had neglected up to this point to talk about the values I chose for this RL circuit when I got all of this data, which is pretty bad. But let me take a look real quick. I'm pretty sure I had it. Yeah, so I use an R value of 100 ohms and an L value of 100 millihenries. Okay, so just keep that just so that you know that that's what I was doing when I made this circuit, because you were probably wondering where the heck I got these values if I didn't have R and L values. Those are the values that I used, okay? And so when we talked about the cutoff frequency previously, we're going to talk about it again right now, but I do need to bring this function over there with me. So let's copy and paste it. So when I talk about the cutoff frequency previously for the RC circuit, you remember that I talked about how the cutoff frequency is the point where the output is equal to 0.707 times the input, or in this case, for the RL circuit, the same thing, V out over V in is equal to 0.707. And we know where that came from. So let's take a look at what happens for the cutoff frequency of an RL circuit. I can rewrite V out over Vs. This is what I did last time. Instead of writing it the way I have it right now, I can write it as Fc over F squared, right, where the Fc is my cutoff frequency. In this case, the Fc is 1 over 2 pi times L over R, okay? In the previous case, it was 1 over 2 pi RC. This time it's 1 over 2 pi L over R. Is that correct? Let me make sure. Yeah, exactly. And so RC is our tau, if you remember that correctly from RC circuits, and L over R is our tau from RL circuits. So kind of see some patterns developing in these circuits, but this is our cutoff frequency. So again, I just said the values were L equals 100 millihenries, R equals 100 ohms. And so again, we would see that at the frequency value where these two are equal, F equals Fc, this whole thing would just go to 1 over root 2, which of course we know is equal to 0.707, right? Let me move that over there a little bit. And so let's see what my Fc is here. It's going to be 1 over 2 pi times L, which is 100 millihenries divided by 100, right? And let's throw that in my calculator. I should, according to my plot here, I should get 159 hertz again. I did that on purpose. Let's do 2 pi times 0.1 over 100. And take the inverse, and I get 159 hertz. All right, so that is the cutoff frequency of the RL circuit. We saw the cutoff frequency of the RC circuit. Very similar concept. We're just setting this. It's basically this particular circuit has a cutoff frequency at 1 over 2 pi L over R. And when the frequency that we're operating at is equal to that cutoff frequency, then the output over the input is equal to 1 over root 2, or 0.707. Okay, this is just it's going to become more apparent and more relevant why we care about this particular value when we do Bode plots, which is the next section of this module. I'm going to wrap this video up right here, and without any further delay, we're going to go ahead and get right into Bode plots in the next video. All right, so I'm going to go ahead and end this.